I'm going to give it a better description later.
Yeah. So just a reminder, sometimes this unit tends to get you to a place where you're like, I'm just not going to get it, right? There you go again. Try to still keep that door open, your mind open, and the more we cover, I tend to always go back and review and remind you of things. So keep your mind open. Don't let an AC. The idea is not to kind of shame you or blame you or do any of that at all. It's just to basically just like push you a little bit, right? How did you do? How did you do? Do you need to review? And that's why I take my time going over the AC, explaining it one more time. That way you have a better idea. And so if you're learning, I'm happy, right? So on page 25, I just wanted to the one question where you had to have people on either end, it's back here. And I just looked up an old exam because I'm like, I'm pretty sure I saw something like that. And one of the exams had that where they had like coaches and teachers, and the coaches had to be on the end for this picture. So it's the same idea. And so I thought page 25 had that right here. You 5 different students, right? 5 students in a Sisler curling team. How many ways can they be lined up for a photo if there are no restrictions? This, you know what? No restrictions. Start thinking universal. Your universal set. Okay. So no restrictions would be just 5 factorial, and that's 120. 120 ways for A. For B, 1 coach on either end, on each end. So I think I will do 14B. Yeah. Let's forget about the coaches. Let's cancel this. Undo. Right? Let's go 14 over here. You are so smart, guys. It's 5 plus 2, right? So 7. 7 factorial. What's 7 factorial? 720? No. No, it's bigger than that. It's bigger than that. It's 5,040 ways. I should probably use my other calculator, otherwise you're gonna be like, how come you get to use those ones? There you go. So that's no restrictions. For B, 1 coach on each end. Okay. I guess 1, 2, 3, 4, 5, 6, 7. Right, coach. In this case, there are just 2 coaches, so this would be 2 and 1. Right? If there had been like, if it's a football team, there's like many coaches. It'd be like, let's say there are 5 coaches altogether. It'd be 5 times 4, right? So that's how that goes. And then whatever is left, 1, 2, 3, 4, 5, right? This whole thing, instead of writing it all out, just go 5 factorial like that. So that's really 2 times 1, which is just 2 times 5 factorial. 5 factorial is 120. Yeah, times 2, that's 240 ways. So if you did the homework, this was on there. And then the coaches together, right? You've got some grouping there. So 2 factorial, and then you've got 7 minus 2 plus 1 for the one group you formed. That's 2 factorial times 6 factorial. And there you go. Times 2, that's 1440. Okay. I'm just going to do 14 here because I just thought bring it up one more time. All right, let's keep going. Yesterday we talked about identical objects on 26 and the fact that, right, we have to divide out. That was going to be my second AC today, but we're not going to do that. But just start thinking of, hey, if there's repeated objects, in this case letters, marbles are classic as well. You want to divide that out, right? So this is basically multiplying down here. Okay. Also, okay, moving forward, I call this a perms checklist. Okay, permutations checklist. You want to start thinking about, before you just go ahead and solve, are there any restrictions put on me? For example, am I allowed to repeat? Is it saying don't repeat? Does somebody have to stand in the front or back, right? Is there a restriction? Then the next thing to think of is it mentioning grouping at all? Do I need to take care of grouping? If so, do it, right? And then the last is check for identical objects, right? The objects that cannot be distinguished in any way. So those are the three things I would always suggest you check for those. I would actually add that to my study sheet, right? Is this at play here? Because sometimes it could be grouping and that. It could be all three layers at the same time. So for example, if you have like marbles, like three different colored marbles, and you're saying, hey, you want the red ones all together, oh, that's grouping. But then you would have to say, hey, wait a minute, there's also some repetition because all the red marbles look the same. So I can't count them individually as I move them, right? So you want to keep that in mind. Let's go to 27. I asked you to do D. I don't know if you did it. I hope you did. This is on 27. Let's see here. Just a few. So if there are no restrictions for Canada, right, to arrange the letters, it's a limited supply. We just go 6 factorial, right, because you've got 6 letters. And then you want to also check for, hey, even though it's not giving you a restriction, says no restriction, we still need to take care of the repeated elements. So there are 3 A's there, 3 A's. Okay, so we're gonna go 3 factorial there to clean that up. So you either slap that into your calculator or you go 6, 5, 4, 3 factorial, like you're breaking down the top, and at the bottom you meet that 3 factorial cancel. I don't want you to forget that that's always something you can do, and so that's 120 ways. First letter is an N, and the last letter is a C. Okay, so we've got 1, 2, 3, 4, 5, 6. So N, C. You only have one N, right, to choose from, and one C to choose from. So that's 1 and 1 right there. And so you got to watch this part. So now we still have 4 factorial left, right, to arrange in the middle. You ready for this one? But you still have to, I'm going to make this, maybe I'll use a red pen or something. You still, once you've done all of this is what we would have done normally, but now I'm adding the layer of identical objects, right? So once you're done all that work, you're going to divide this whole thing by how many A's are there? 3 A's, right? So we're going to go divide it by 3 factorial, like that. So this all simplifies to, right? 1 times 1 doesn't really matter. So it really just comes down to 4 factorial over 3 factorial. And this is 4 times 3 factorial if you break down the top, 3 factorial if you break down the bottom, if you leave the bottom like that, and you're left with 4 ways to arrange that. Okay. So back to there was a restriction put on us, okay? No grouping in this case, so we skipped that one, but we did have to take care of the identical objects, right? Don't forget about it. First letter is an A. So 1, 2, 3, 4, 5, 6. First letter is an A. So watch this. How many A's do you have to pick from? You got 3. So you go, have 3. So you could do the branches thing. You could do this A or that A or the other A, but I'm not going to go there. So how many are left here? Right? There's 5 factorial left here. Because you could take, if you grab one of the A's, you could take the other two with you and use them in the other one, right? Because you're only grabbing one at a time. And then all of this, remember, divided by 3 factorial. So don't forget to get rid of the repeats. Okay, so this ends up being 3 times 5 factorial at the top here, divided by 3 factorial right there. You can just type this into your calculator, or I'm going to go 3 times 5 times 4 times 3 factorial. So I'm breaking down the 5. And at the bottom, I have my 3 factorial. Boom. Right? 5 times 4 is 20, times 3 is 60. So if all letters had been different, do not worry about this, right? Do not worry if all letters have been different. Do I need to make it even more obvious here? I think so. Like, where does this always come from, right? I will highlight the 3 A's up here. Like, right, that's why I'm getting rid of that. So whatever color you have, highlight that, the 3 A's, and then just make it come with you all along. Okay. What's our time like? Okay. Here it is again, another example. Mr. Rick says decorating for his son's birthday. That's always my job. Like a gazillion balloons. That's where the big lungs come in handy. He has 4 blue, 5 green, 3 yellow, 2 purple balloons, right? So right there we realize, okay, we've got 14. Okay. He wonders how many possible combinations are possible if you were to tie them onto a string and hang them across the ceiling. So just all beside each other. Okay. So how many ways can that be arranged? You should realize balloons are non-distinguishable. They're identical. It's another way of, I never know what the province is going to do, right? So I'm gonna use both, right? You can't distinguish between them. They're identical, right? So you would have to go 14 factorial. So either you make 14 little blanks and just go 14, 13, 12. Good luck with that, right? And then you're going to divide out the repetition. So no letters. In this case, it's just balloons. So you got to go 4 factorial for the blue ones, 5 factorial for the green ones, 3 factorial for the yellow, and 2 factorial for the purple. You could technically just write down 2 if you wanted to, but it should always be factorial, just to make sure you don't mix that up. Okay, so it's up to you how you want to do this. Let's just maybe type that all in. So I'm going to figure out what 14 factorial is. Oof, that's a big number. I'm just going to keep it like this. So when you get that, we're going to go 18.717 ... times 10 to the power of 10. Okay, that's how you're going to write that for now. It's gonna become smaller, right? Because we're going to divide out the repetition. So now I'm going to do the bottom separately. 4 factorial times 5 factorial. Oh yeah, now I'm reminded of giving you shortcuts. Times 6. 3 factorial is 6 times 2. Okay, so you have that at the bottom there. And because you have these amazing calculators, you just go copy, right, divide it by whatever you have in the denominator, and that's what you end up getting. So it's not 14 factorial, because if you were to shift all the blue ones, if you were to move them, it looks exactly the same. So you can't count that as like a separate permutation. So we need to divide out, right? Maybe I'll do this, right? We divide out the identical objects. That's what's happening here. How many arrangements if the same colors stay together? And I know some of these examples are a bit crazy. Like on a test, I wouldn't mix too many things together. But if you want the arrangements, if the same colors stay together, so you've got grouping, and identical. That's what's in the mix here. You've got some grouping and identical. Let's take care of the grouping first. So you would go 4 factorial. This is going to cancel out quite nicely, by the way. 4 factorial, 5 factorial, 3 factorial, 2 factorial, right? So all the groups we're making 4 different groups because the like colors stay together. Then you go 14 minus 5, sorry, minus 4, minus 5, minus 3, minus 2, plus, how many groups have I created? 1, 2, 3, 4, right? So you're going to add 4 and then slap a factorial on there. Hold on, you think you're done, right? We still need to get rid of all the repetition, right? So the 4 factorial, we need to divide that out. The 5 factorial, we need to divide that out. The 3 factorial and the 2 factorial. We can't double count. Do you see what's happening there? Cancel, 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 cancel. It's all gone. So you're really just left with 4 factorial, guys. That's all you're left with, which is 24 ways. So if you group and you got to get rid of the identical, there's really just 24 different arrangements you can make under those circumstances. I tried something here. Okay, so let's say, right, my son asks me to paint a unique smiley face on every single balloon. Unique, right? How many ways can they be arranged now? They are now distinguishable. Okay, they are now unique. Okay, so really it's just 14 factorial, which is that big number we had up there. If every single one were unique, that's how you would do it. Okay. Okay. I'm going to ask you to try page 28 and 30, but don't pack just yet. Oh yeah, the bell is about to go. I'm going to say 28 and 31. It's not that much. Okay. It's not that. So not 231, but and 31. 28 and 31. Okay. Have a good one, guys.